Okay, grade 12. So we're on question 2, and 2.1 says, consider the geometric series where 4, 2, 1, a half. So as you can see, they are being cut into 2 the whole time. So 4 divided by 2 is 2, and 2 divided by 2 is 1. So since that is happening, they're really just being multiplied by a half each time. So 2.1.1 says, does the series converge? Justify your answer. So does this converge? Well, for a series to converge, your ratio needs to be greater than -1, but less than 1. Okay, so that is just the answer in like a equation sense. We can go into a more detailed explanation on that, but I think maybe I'll speak more about that in another video and what it really means for a series to converge. So remember what I said the ratio is. So that's really all you have to do here. Find the ratio. So the ratio you could find by saying the second term divided by the first term. And that gives us a half. So we know that a half is greater than -1, but it is smaller than 1. And so therefore the series does converge. Okay, so that is 2.1.1. Moving on to the next question. The next question, they want us to find or calculate the sum to infinity. So you just need the formula. The sum to infinity is equal to a over 1 minus r. So our a value here is our first term, which is 4. So that is 4 over 1 minus our r is a half. And then if we calculate this, it's really just 4 over 1 minus a half is a half. If you say 4 divided by a half, you're going to get 8. And that is your answer. Okay, moving on to the next question, 2.2. Okay, so question 2.2 says, given, and we have a case of sigma here. So sigma just means sum. Given the sum, starting where p is equal to k and ending at 10, of a series with this formula, 3 to the power of p minus 1, given that sum, okay, the sum of that series is equal to 29,520, we need to calculate the value of k. Okay, so this one is a little different because they put k here instead of on here. So it's just something that's a little different, but let's just try to look at it the way we would normally look at a sigma question. So they want you to find k, no problem. Since this is sigma, it's speaking about the sum of a series. And this is the sum of what type of series? Well, you have 3 to the power of p minus 1. And as you can see, your variable is on your exponent. So it means that this is a geometric series. Okay, so now that we know it's a geometric series, let's also just understand a few things about this. When you have the sum, the number that they have here is the value that you're going to start with. Meaning, in order to get your first term, you would take the value that they gave you here and you would substitute it in place of your variable in your formula, right? And then the number here is where you're going to end at. Again, you'll take that 10 and substitute it into there to get your last term in this series. So since they're still asking us to find the value of k and we know it's sigma, let us look at the formula we have here. Since our formula is 3 to the power of p minus 1. Okay, so this is the TN formula, or let's call it the TP formula since p is our variable here. So since our formula is this, let's compare it to the original, the general formula of a geometric series. And that formula looks like this. Tn is equal to a multiplied by r raised to the power of n minus 1. Okay, so if that is the case, let us just see. Do you see that you have p minus 1 here and n minus 1? So that's a good thing because now it means that they're really in the same format. And now, based on that, we can actually find out what r is. But here's the thing. If we can see that, okay, this is r, clearly, why can't we say a should be 1? Since that's the coefficient of the 3 here. Okay, there's an invisible 1 there, technically. Now, the reason you can't say that is because with sigma, they tell you where to start. Okay, they tell you p is equal to a specific number, and by default, that has to be your a value. That has to be your first term. Okay, so let's not make that mistake and call that 1. So what we can do here is, since we know what r is, let's actually focus on the main goal. The main goal is to use the sum formula to find k. because this is sigma, okay? It's the sum of the series. So the sum formula, since we know r is 3, I'm just going to say that r is equal to 3. So since we know that, so you see r will not change. There's no confusion in that. As long as it is the thing with the exponent and it is in the same format, then that is r. So our sum formula is Sn is equal to a multiplied by r to the power of n minus 1 all over r minus 1, okay? And let's just figure out everything we need to find here. So in order to find k, we need to know what n is, we need to know what a is, and we need to know what r is going to be as well. Now n, I always mention this, I've mentioned this a lot. N, please note, n does not stand for the number that you end at. Many a times it will be the number that you end at, and that's only in situations where, let's say, p is equal to 1. And then in this situation, right, n would literally just be 10 because there are 10 terms. From term 1, from p equals 1, 2, 3, all the way to 10, there will be 10 terms. But once they change this, it's a little different, okay? So how I want you to see n is the number of terms, but how you find it is simply by saying you take the top, or let me actually stop calling it the top. Let's say you take the number that you end at and you subtract it by the number that you start at and you add 1. That's how you find n. So with our calculation of n, it's going to be n is equal to the number we end at is 10 minus the number we're starting at is k, and then plus 1. And so if you simplify this, this is n is equal to 10 plus 1 is 11, so it's 11 minus k. And we're going to leave that as n. That is our value for n. So we have n. Do we have a? Not yet. Well, we have to find a. Remember, a is your first term. It doesn't mean you substitute 1 in place of your variable in your term formula. Okay, you don't substitute 1 in this case. What you're going to do is this. Because they say p is equal to k, they didn't even tell you where you start at. We need to find out that. Since this is where we start at, to find term 1, which is a, so t1 is a, to find that, you're going to have to say, use your formula, you say 3 to the power of, and in place of p, since they told us we are starting at k, we need to substitute k to find our first term for this particular series. So I'll substitute in place of that k, and then minus 1. That's all I have there. And I'm going to treat that as my first term, because it is my first term, since I don't know what k is. Okay, so we have r, we have a, and we have n, and we are ready to start. So let's go ahead. So we have the sum of how many terms? This is the sum of n, we know is 11 minus k. So I'll call that s of 11 minus k is equal to, our a value is 3 to the power of k minus 1. This is just a case where you just have to trust the process and trust that you actually have found each of the values that you needed to find correctly. And then r is 3. So 3 to the power of, well, we know n is 11 minus k minus 1 all over r minus 1, which is 3 minus 1. Okay, then s of 11 minus k, or really the sum of this series that we're speaking about, is 29,520. So we're going to put that there. 29,520 is equal to, and let's go, we have 3 to the power of k minus 1. And then we have, well, I guess we can just multiply those already. So when you're multiplying, since it's 2 terms inside, it's going to distribute like that. And so 3, they have the same base. So you're going to add the exponents, keep the base the same, and add the exponents. If you say k minus 1 plus 11 minus k, you don't need brackets because we're adding. So what's going to happen is you're going to have your k and your k cancel, because they will simplify to 0. And then 11 minus 1 is 10. So we have 3 to the power of 10 there. And then this multiplied by negative 1 will just stay negative 3 to the power of k minus 1. Okay, so that there's no confusion there. Remember, the negative is outside. And it's actually this base of 3 being raised to the power of k minus 1. And we have that over 3 minus 1 is 2. Okay, so this is what we have so long. As you can see, k is nicely on its own. We just have to find our way to get to it. So the first thing that is stopping us from getting to k would be this 2. So let's go ahead and get rid of the 2. Since here you're dividing by 2, to get rid of the 2, you need to multiply by 2. But you have to do so on both sides since this is an equation. So what do we have when we say 29,520 multiplied by 2? That gives us 59,040. Okay, and then we have is equal to, and this is 3 to the power of 10 minus 3 to the power of k minus 1. Okay, so this is what we have so long. Let's keep going. Now, what do we have to do next? Well, the thing is, I see that this is negative, and I don't like the thing being negative when it includes the variable we're looking for. So what I'm going to do is I'm going to take that over. Okay, so when I take this over, it becomes positive 3 raised to the power of k minus 1 is equal to, and I'm going to simplify this 3 to the power of 10. So 3 to the power of 10 on the calculator is, we have 59,049. Okay, and what I'm going to do with this 59,040, I'm going to take that one over. So it becomes negative 59,040. Okay. Then we have 3 to the power of k minus 1. As you can see, 59,000 and 59,000 will cancel. 49 minus 40 is 9. So we have 9 there. And so 3 to the power of k minus 1 is equal to, make the bases the same since it's an exponential equation. It's 3 to the power of 2 is 9. And now that the bases are the same, we can therefore say that k minus 1 is equal to 2. And therefore, k is equal to, take that negative 1 over, k is equal to 3. And that is our answer for k. You can go ahead and test it out. You can go ahead and take k is equal to 3 and put it there. And then find your first term, second, and third term. Then find the sum of that series, making sure that n, you find n by saying top or the end minus the start plus 1, and then you actually find that you will get this number. Okay, so k is equal to 3, and that is it for question 2. And let's move on to question